Picture a vast cosmic nursery, a realm where the very fabric of our universe comes to life. This is not a scene from science fiction, but a tangible reality unfolding in the night sky above us. Imagine, if you will, an expanse so immense that it dwarfs our comprehension, yet so intricate that it crafts the building blocks of existence itself. Here, amidst swirling clouds of gas and dust, painted in hues of crimson and azure, new stars flicker to life, and planets coalesce from cosmic debris. This celestial spectacle is not hidden from view, tucked away in some remote corner of the galaxy. No, this marvel of creation is visible to the naked eye, a testament to the grandeur of the cosmos that's within reach of anyone who dares to look up on a clear, dark night. Ladies and gentlemen, welcome to the Orion Nebula, one of the most breathtaking and revealing celestial displays in our night sky. This cosmic cradle of creation is not just a pretty sight. It's a window into the very processes that shaped our own world and continue to forge new realms across the universe. Now, let me ask you this. What if I told you that at this very moment, you could gaze up at the sky and witness a place where hundreds of suns and thousands of planets are being born? It's not science fiction. It's happening right now, in real time, just a glance away. Imagine a portal that could transport us back in time, allowing us to witness the birth of our own solar system. While time travel remains the stuff of dreams, the Orion Nebula offers us the next best thing, a living, breathing example of how our cosmic neighborhood came to be. You see, the Orion Nebula isn't just a beautiful smudge of light in the night sky. It's a cosmic time machine, a window into our celestial past, and a glimpse into the future of countless worlds yet to form. In its glowing clouds, we can see the very processes that gave rise to our Sun, our Earth, and everything we've ever known. As we delve into the secrets of the Orion Nebula, we're not just exploring a distant corner of space. We're uncovering the story of our own origins, written in the stars. We're witnessing the grand cycle of cosmic creation that has been playing out for billions of years and will continue long after we're gone. So, are you ready to embark on a journey through time and space? Are you prepared to witness the birth of new worlds and unravel the mysteries of our cosmic heritage? Then let's dive into the magnificent realm of the Orion Nebula, where the past, present, and future of the universe converge in a spectacular cosmic dance. If this cosmic journey through the Orion Nebula has ignited your curiosity about the wonders of the universe, don't let your exploration end here. Hit that like button to fuel our cosmic voyage, and subscribe to the Exploring the Universe channel to continue unraveling the secrets of the cosmos together. By subscribing, you'll join a community of stargazers, science enthusiasts, and cosmic explorers as we venture deeper into the mysteries hidden in the depths of space and time. From the birth of stars to the dance of galaxies, every video is a new adventure waiting to unfold. So, what are you waiting for? Like this video, click that subscribe button, and let's keep exploring the universe together. The cosmos is calling. Will you answer? The Orion Nebula, also known as Messier 42, is a prominent feature in the night sky, located in the constellation of Orion. To find it, look for Orion's belt, 3 bright stars in a row. Just below the belt, you'll see a group of stars forming Orion's sword. The middle star in this sword isn't a star at all, but the glowing Orion Nebula. What makes the Orion Nebula truly remarkable is its visibility to the naked eye. On a clear, dark night, it appears as a fuzzy patch of light. With binoculars or a small telescope, its ethereal beauty begins to unfold, revealing wisps of gas and dust illuminated by the hot, young stars within. The nebula is visible throughout much of the year, but is best observed during winter months in the northern hemisphere and summer months in the southern hemisphere. Its prominence in the night sky has made it a favorite target for amateur astronomers and a crucial subject of study for professionals. The sheer scale of the Orion Nebula is mind-boggling. It spans about 24 light-years across, which means it would take light itself 24 years to travel from one end to the other. To put this into perspective, our entire solar system, from the Sun to the outer reaches of the Kuiper Belt, is only about 1 light-year across. The Orion Nebula could comfortably house dozens of solar systems like ours. Despite its enormous size, the Orion Nebula is relatively close to us in cosmic terms. It lies approximately 1,344 light-years away from Earth. This means that when we look at the nebula, we're seeing light that left it over 1,300 years ago, during the early Middle Ages on Earth. The combination of its size and relative proximity makes the Orion Nebula the closest massive star-forming region to Earth. This unique position has made it an invaluable laboratory for astronomers studying the processes of star and planet formation. The Orion Nebula has a rich history of human observation and discovery that spans centuries. While not recognized as a nebula, the fuzzy patch in Orion's sword was noted by various ancient cultures. The Maya of Central America had myths associated with the region of Orion's sword. Galileo Galilei became the first person to observe the nebula through a telescope, though he only recorded it as a cluster of stars. Nicolas Claude Fabry de Peyresque is credited with the first documented discovery of the nebula. Charles Messier included the Orion Nebula in his famous catalogue of astronomical objects as M42. With the advent of photography and spectroscopy, astronomers began to understand the true nature of the nebula. William Huggins used spectroscopy to prove that the Orion Nebula consisted of glowing gas, not stars. The development of radio astronomy and infrared detectors allowed scientists to peer through the nebula's dusty veils, revealing the processes of star formation within. Space-based telescopes like Hubble, Spitzer, and now James Webb have provided unprecedented views of the nebula, allowing us to study its intricate structures and ongoing stellar nursery activities in exquisite detail. Each technological advance has peeled back another layer of the Orion Nebula's mysteries, transforming it from a fuzzy patch of light into a complex, dynamic laboratory for studying the birth of stars and planets. The Orion Nebula is a vast cloud of gas and dust, primarily composed of the most abundant element, making up about 90% of the nebula's mass. The second most common element, comprising about 9% of the nebula. The remaining 1% includes oxygen, carbon, nitrogen, and trace amounts of other elements. Interspersed within this gas are tiny dust particles, primarily made of silicates and carbonaceous materials. While dust makes up only about 1% of the nebula's mass, it plays a crucial role in star and planet formation. The nebula is energized by the hot, young stars at its heart. These stars, particularly the four massive stars known as the Trapezium, emit intense ultraviolet radiation that ionizes the surrounding gas, causing it to glow. This process creates the beautiful colors we observe: red from hydrogen, green from oxygen, and blue from ionized oxygen. Hydrogen is the primary fuel for star formation. The process begins when a portion of the nebula becomes slightly denser than its surroundings. This increased density creates a gravitational pull, attracting more material. As more mass accumulates, the gravitational force increases, leading to a runaway process of collapse. As the collapsing cloud of primarily hydrogen gas contracts, it heats up. When the core reaches about 2000 Kelvin, molecular hydrogen breaks down into atomic hydrogen. At about 10,000 Kelvin, the hydrogen atoms become ionized. Finally, when the core temperature reaches about 15 million Kelvin, nuclear fusion begins, marking the birth of a new star. While hydrogen is the star's primary fuel, other elements play crucial roles. Helium is the product of hydrogen fusion and will become fuel in later stages of massive stars' lives. Heavier elements act as coolants, allowing portions of the nebula to collapse by radiating away heat. Without these elements, star formation would be much less efficient. Dust particles provide surfaces for certain chemical reactions and play a vital role in planet formation. The Orion Nebula is not a homogeneous structure but a complex tapestry of different regions, each with unique characteristics. At the heart of the nebula lies this group of hot, young stars. Their intense radiation ionizes the surrounding gas, creating the brightest part of the nebula. This is the brightest part of the nebula, surrounding the trapezium. It's characterized by ionized gas glowing in vibrant colors. A dense ridge of gas and dust that marks the boundary between the hot, ionized region near the trapezium and the cooler, neutral gas beyond. Scattered throughout the nebula are numerous disc-shaped clouds of gas and dust surrounding young stars. These are the nurseries where planets are born. These are jets of gas ejected from very young stars, creating shock waves as they collide with surrounding nebula material. Beyond the visible nebula lies a vast, cold cloud of molecular gas. This region is invisible to optical telescopes but can be studied with radio and infrared instruments. It's here that the next generation of stars is beginning to form. Each of these regions provides astronomers with unique insights into different stages of star and planet formation, making the Orion Nebula an invaluable cosmic laboratory. The birth of a star is a cosmic dance of gravity, pressure, and nuclear physics that unfolds over millions of years. Let's break down this awe-inspiring process. It begins with a dense patch in a molecular cloud, like the Orion Nebula. This patch, slightly denser than its surroundings, starts to collapse under its own gravity. As the cloud collapses, it may break into smaller fragments, each of which could become a star. The collapsing fragment continues to contract, becoming denser and hotter. At this stage, It's called a protostar. It's not yet hot enough for nuclear fusion, deriving its energy from gravitational contraction. The protostar continues to grow by accreting matter from its surrounding envelope of gas and dust. For stars similar in mass to our Sun or smaller, they enter the T-Tauri phase. These stars have strong stellar winds and are highly variable in brightness. When the core temperature reaches about 15 million Kelvin, nuclear fusion of hydrogen into helium begins. This marks the birth of a true star. Once fusion stabilizes, the star enters the main sequence, where it will spend most of its life. This process can take anywhere from 100,000 years for massive stars to tens of millions of years for smaller stars like our Sun. At the heart of the Orion Nebula lies a remarkable group of stars known as the Trapezium. This tight cluster of stars, named for its trapezoidal shape, is a jewel box of stellar formation. The Trapezium consists of 4 primary stars, labeled A, B, C, and D, with 2 additional fainter stars, E and F, also part of the system. These stars are extremely young in astronomical terms, estimated to be less than 300,000 years old. They're primarily massive, hot O-type and B-type stars. The intense ultraviolet radiation from these stars, particularly from Theta 1 Orionis C, the brightest member, ionizes the surrounding gas, causing the nebula to glow. The trapezium can be resolved into individual stars with a small telescope, making it a favorite target for amateur astronomers. This cluster provides astronomers with a nearby laboratory to study the early stages of stellar evolution for massive stars. The Orion Nebula is an invaluable resource for understanding stellar evolution. Within the nebula, we can observe stars at various stages of formation, from protostars to young main sequence stars. The nebula contains stars of various masses forming simultaneously, allowing us to compare how mass affects stellar evolution. We can study how the dense nebula environment affects star formation and early stellar life. The nebula shows us how young stars affect their environment through radiation and stellar winds, potentially triggering or hindering further star formation. The trapezium and other clusters in the nebula help us understand how stars interact in dense stellar nurseries. By studying stars at different stages within the same nebula, astronomers can refine models of how long various phases of stellar evolution take. Protoplanetary disks, often called proplyds, are the nurseries where planets are born. As a protostar forms, conservation of angular momentum causes the surrounding material to flatten into a rotating disk. These disks are made of gas and dust left over from the star formation process. Typically, they have a radius of 1001000 astronomical units, AU, and a mass of about 1 to 10% of the central star. Over time, the disk material can coalesce to form planets, asteroids, and comets. In the Orion Nebula, we can directly observe these disks as dark silhouettes against the bright nebula background. The Hubble Space Telescope has provided groundbreaking observations of planet formation in the Orion Nebula. Hubble has captured detailed images of numerous proplyds, showing their structure and interaction with the nebula environment. Some proplyds show dark lanes, which may indicate the presence of forming planets clearing out their orbits. Hubble's observations have allowed astronomers to estimate the sizes and masses of these disks, crucial for understanding planet formation potential. Hubble has shown how the harsh ultraviolet radiation from nearby massive stars is eroding these disks, providing insights into how environment affects planet formation. By observing the same regions over years, Hubble has captured the dynamic nature of these systems, showing changes that hint at ongoing planetary formation. Studying the Orion Nebula's planetary nurseries provides valuable insights into our own solar system's formation. The presence and erosion of disks in Orion help us understand how long our solar system's protoplanetary disk might have lasted. The sizes of Orion's proplyds are comparable to what models suggest for our early solar system, supporting current theories. Spectroscopic analysis of Orion's disks reveals similar compositions to what we believe our early solar system contained. Seeing how nearby massive stars affect disk evolution in Orion helps us understand how our solar system might have been influenced by its stellar neighborhood. The various stages of planet formation observed in Orion align with theoretical timescales for our solar system's formation. The wide variety of disk sizes and masses in Orion supports the idea that diverse planetary systems are common, explaining the variety we see in exoplanet discoveries. By studying the Orion Nebula, we're not just looking at distant alien worlds. We're looking at a reflection of our own cosmic history, seeing processes that likely played out in our own neighborhood some 4.6 billion years ago. This cosmic connection reminds us that we are indeed children of the stars, our existence intimately tied to the grand processes we observe in Orion's stellar nursery. The Orion Nebula serves as a cosmic time machine, offering insights into the chemical processes that occurred in the early universe. By studying the composition of the nebula, astronomers can infer the ratios of elements present in the early universe, particularly hydrogen and helium. The nebula shows how the first generations of stars enriched their environment with heavier elements, a process crucial for the formation of planets and eventually life. The cool, dense regions of the nebula allow us to observe how complex molecules form in space, mimicking conditions in the early universe. The nebula's dust grains provide clues about the formation of the first solid particles in the universe, which were essential for planet formation. By analyzing the isotopes of various elements in the nebula, scientists can trace the nucleosynthesis processes that occurred in previous generations of stars. The Orion Nebula is a rich hunting ground for astrobiologists searching for the precursors of life. Astronomers have detected a variety of organic molecules in the nebula, including formaldehyde, methanol, and even more complex compounds. Some of the molecules found are precursors to amino acids, the building blocks of proteins essential for life as we know it. The nebula contains vast amounts of water in various forms, from ice to vapor, a key ingredient for life. The abundance of carbon-based molecules in the nebula provides insights into the cosmic carbon cycle, crucial for organic chemistry. By studying the chemical reactions occurring in the nebula, scientists can better understand the prebiotic chemistry that may have led to life on Earth and potentially elsewhere. Nebulae like Orion play a crucial role in cosmic chemical evolution. The massive stars in the nebula create heavy elements through nuclear fusion and distribute them when they explode as supernovae. These heavy elements are ejected into the surrounding space, enriching the interstellar medium from which future stars and planets will form. This process of star formation, element creation, and distribution represents a cosmic recycling system that gradually increases the universe's complexity. The enriched material from the nebula will eventually contribute to the formation of new stars and planetary systems, potentially with the necessary ingredients for life. By comparing the elemental composition of different regions in the nebula, astronomers can track how quickly and efficiently this enrichment process occurs. If the idea of new worlds being born at this very moment makes your heart race, hit that like button. Your support helps us continue exploring these cosmic wonders with you. Spectroscopy is a crucial tool for unraveling the mysteries of the Orion Nebula. By analyzing the spectrum of light from the nebula, astronomers can identify the elements and molecules present. The intensity and width of spectral lines provide information about the temperature and density of different regions in the nebula. The Doppler shift of spectral lines reveals the motion of gas within the nebula, helping us understand its dynamics. Spectroscopy shows which atoms are ionized, indicating the energy levels in different parts of the nebula. The relative strengths of spectral lines help determine the abundance ratios of various elements, crucial for understanding the nebula's chemical evolution. Different wavelengths of light reveal various aspects of the Orion Nebula, shows the glowing ionized gas and reflects off dust, giving us the familiar colorful image of the nebula. Penetrates dust clouds, revealing hidden stars and cooler regions where star formation is actively occurring. Traces the hottest and most energetic regions, often associated with young, massive stars. Detect the presence of extremely hot gas and high-energy phenomena like stellar winds colliding. Reveal cool molecular clouds and allow us to track the motion of gas through the nebula. Detects cold dust and molecules, providing insights into the earliest stages of star formation. The James Webb Space Telescope and other advanced instruments have provided groundbreaking insights. Has provided unprecedented views of protoplanetary disks, revealing their structure and composition in exquisite detail. New observations have detected increasingly complex molecules, pushing our understanding of cosmic chemistry. Advanced infrared capabilities have penetrated previously opaque regions, revealing new stellar nurseries and young stars. High-resolution spectroscopy has mapped the complex gas flows within the nebula, showing how stellar winds shape the environment. New data has provided insights into the size, composition, and distribution of dust grains, crucial for understanding planet formation. Advanced polarimetry has mapped magnetic fields within the nebula, showing their role in star formation. Improved spectroscopic capabilities have refined our understanding of elemental abundances, providing clues about the nebula's history and future. These recent observations are revolutionizing our understanding of the Orion Nebula, star formation, and the early stages of planetary system development. As we continue to study this cosmic nursery with increasingly powerful tools, we're not just learning about distant space phenomena. We're uncovering the story of our own cosmic origins and the potential for life elsewhere in the universe. The future of the Orion Nebula is a fascinating subject of study for astronomers. Based on our current understanding of stellar evolution and nebula dynamics, we can make several predictions. Over the next few million years, the intense radiation and stellar winds from the massive stars in the Trapezium Cluster will continue to erode and disperse the nebula's gas and dust. As the gas disperses, the nebula's overall luminosity will gradually decrease. The iconic glowing appearance we see today will slowly fade. As the nebula becomes less dense, more of the stars forming within it will become visible to us. The Trapezium Cluster will likely disperse over time due to gravitational interactions between its members, with some stars being ejected from the cluster. Some of the most massive stars in the nebula may end their lives as supernovae within the next few million years, dramatically altering the nebula's structure and chemical composition. These supernovae, along with the ongoing effects of stellar winds, may trigger new episodes of star formation in the denser regions of the remaining molecular cloud. Eventually, perhaps in 10 to 20 million years, most of the gas will be dispersed or used up in star formation, leaving behind an open cluster of stars similar to the Pleiades. The stars and planetary systems currently forming in the Orion Nebula face varied futures. Many of the protoplanetary disks we observe will evolve into full planetary systems, though some may be disrupted by close encounters with other stars or eroded by intense radiation. The young stars will continue to contract and stabilize, eventually reaching the main sequence where they will spend most of their lives. In many forming systems, planets will likely undergo orbital migration, potentially resulting in hot Jupiters or compact systems of super-Earths. Some of the forming Earth-like planets in the nebula's outskirts might evolve to be potentially habitable, though those closer to the intense radiation of the trapezium may face challenges. Some of the smallest protostars may never accumulate enough mass to ignite hydrogen fusion, instead becoming brown dwarfs. Gravitational interactions within the cluster may result in some stars and planets being ejected, becoming free-floating objects in the galaxy. The Orion Nebula serves as a template for understanding other star-forming regions. By studying different parts of the Orion Nebula, we can better estimate the timescales for various stages of stellar and planetary formation in other nebulae. Orion shows us how the presence of massive stars affects star formation in their vicinity, which can be applied to other regions. The evolution of the Trapezium Cluster provides insights into how young star clusters in other nebulae might evolve. Studying how stellar winds and radiation shape the Orion Nebula helps predict how these processes will affect other star-forming regions. The changing chemical composition of the Orion Nebula over time informs models of chemical enrichment in other nebulae. The distribution of stellar masses in Orion helps refine our understanding of the initial mass function, crucial for predicting star formation outcomes in other regions. While the Orion Nebula is perhaps the most famous star-forming region, it's instructive to compare it with other notable nebulae, Eagle Nebula, known for the iconic Pillars of Creation. Similar to Orion in that it's a site of active star formation, generally older than the Orion Nebula, with more evolved stars. Located about 7,000 light-years away, compared to Orion's 1,344 light-years. Crab Nebula. Unlike Orion, it's a supernova remnant, not a star-forming region. Much younger, formed by a supernova observed in 1054 AD, energized by a central pulsar, unlike the young stars in Orion. Showcases the end stages of stellar evolution rather than the beginning. Lagoon Nebula. Another star-forming region, similar to Orion but larger. Contains a young open cluster like the trapezium, called NGC 6530, located about 4,100 light-years away, making it less detailed in our observations. Trifid Nebula. Combines elements of emission, reflection, and dark nebulae. Younger than the Orion Nebula, with star formation at an earlier stage. Notable for its three-lobed appearance caused by dark dust lanes. The Orion Nebula holds a special place in astronomical research for several reasons. At only 1,344 light-years away, it's the closest massive star-forming region to Earth, allowing for exceptionally detailed observations. It's bright enough to be seen with the naked eye, making it accessible to amateur astronomers and facilitating long-term studies. The nebula is relatively young, about 2 million years old, and still actively forming stars, providing a real-time laboratory for studying star birth. It contains a wide range of astronomical phenomena in one region: massive stars, protostars, brown dwarfs, planetary disks, and complex molecular clouds. The presence of this young, dense star cluster allows us to study stellar interactions and cluster evolution up close. Its well-studied nature makes it a crucial benchmark for calibrating observations of more distant star-forming regions. It's observable across the entire electromagnetic spectrum, from radio to X-rays, providing a comprehensive view of its processes. The nebula showcases various environments, from the harsh radiation-filled center to the more benign outskirts, all within one structure. It has been studied for centuries, providing a long baseline of observations that help track changes over time. Its beauty and prominence have made it an ambassador for astronomy, engaging the public in space science. The Orion Nebula's unique combination of proximity, activity, and diversity makes it an unparalleled cosmic laboratory. By studying Orion, we're not just learning about one nebula, but gaining insights that help us understand star formation and stellar evolution throughout the universe. As our instruments and understanding improve, the Orion Nebula continues to be a key site for pushing the boundaries of astronomical knowledge. The Orion Nebula stands as a cosmic icon, representing far more than just a beautiful celestial object. It embodies our quest to understand the fundamental processes that shape our universe. The nebula serves as a vivid illustration of stellar birth, showcasing the intricate processes that lead to the formation of stars and planetary systems. It offers insights into the complex chemistry of space, demonstrating how elements combine to form the building blocks of planets and potentially life itself. From protostars to massive, bright stars, Orion presents a snapshot of various stages of stellar life, helping us piece together the stellar life cycle. The nebula illustrates the delicate balance between gravity, radiation pressure, and magnetic fields that govern cosmic structures. As one of the most studied objects in the sky, Orion serves as a crucial testing ground for our theories of star formation and nebula physics. The Orion Nebula reminds us of the ongoing drama of creation playing out in the cosmos. Every time we look at Orion, we're witnessing the birth of new stars and planets, a process that has been ongoing for billions of years and continues ceaselessly. Unlike many cosmic processes that occur over timescales far beyond human perception, the dynamic nature of Orion allows us to observe changes within human lifetimes. The nebula's glowing gases and dust, sculpted by stellar winds and radiation, create a celestial spectacle that has inspired humanity for generations. Contemplating Orion reminds us of our place in the universe. We are part of this ongoing cosmic story, made of the very star stuff we observe in the nebula. Despite centuries of study, Orion still holds many secrets, from the exact mechanisms of massive star formation to the potential for life-bearing planets within its realm. The Orion Nebula serves as a cosmic bridge across time. The nebula showcases conditions similar to those in which our own solar system formed some 4.6 billion years ago, offering a glimpse into our cosmic origins. Current studies of Orion push the boundaries of our technological and theoretical capabilities, representing the cutting edge of human knowledge. The young stars and forming planets in Orion hint at the potential future of our galaxy, and possibly at the fate of our own solar system billions of years from now. The history of Orion observations mirrors the progress of human technology, from early telescopes to modern space-based observatories. As we look to the future of space exploration, Orion reminds us of the wonders waiting to be discovered and the importance of continuing our cosmic journey. By understanding the processes in Orion, we gain insights into star formation throughout the universe, connecting our local neighborhood to the cosmos at large. Orion illustrates the cycle of stellar birth and death that has produced the elements necessary for life, linking us intimately to the cosmic narrative. The Orion Nebula is not just a distant object of study, but a mirror reflecting our cosmic heritage, our current quest for knowledge, and our future aspirations as a species venturing into the stars. It stands as a testament to the beauty, complexity, and interconnectedness of our universe. If this journey through Orion's cosmic nursery has ignited your curiosity about the wonders of the universe, don't stop here. Subscribe to the Exploring the Universe channel to continue unraveling the secrets of the cosmos. Together, let's explore the mysteries hiding in the depths of space and time. By subscribing, you'll join a community of cosmic explorers, gaining access to regular updates on the latest astronomical discoveries, in-depth explorations of fascinating cosmic phenomena, stunning visualizations of celestial wonders, explanations of complex astrophysical concepts in accessible terms, discussions on the implications of our expanding cosmic knowledge. Remember, every star you see in the night sky has a story as fascinating as Orion's. Each subscription helps us bring more of these cosmic tales to light. So hit that subscribe button, turn on notifications, and let's embark on an endless journey of cosmic discovery together. The universe is vast, but with curiosity as our guide and knowledge as our ship, there's no limit to how far we can explore. Join us in exploring the universe, where every video is a new adventure in the cosmos.